Hello everyone, welcome back to Gap.com's YouTube channel. My name is Spandan and for you today we have LeetCode's problem of the day. So, the name of today's problem is make string a subsequence using cyclic increments. You can go through the question on your own. I will head on to the notebook and will explain you what the question actually wants. Heading on to the notebook, let's add the question here for our ease. So, this is the question. We have been given a few sample inputs here and here and here. So, what it says, we are given two strings, string 1 and string 2, which will be zero index strings containing a sequence of alphabets. And we have to make sure that string 2 is a subsequence of string 1. Subsequence means this must be a part of this string. It has nowhere been said that it's a contiguous substring, so it can be separated. That is, there might be something else between these. Suppose here we have AD. We could have a string A, B, C, D. Here we will ignore B and C. We'll just focus on A and D because these conditions are met. But in this string, as you can see, it is only A, B, C. We don't see a D here. So how is it giving us a value true? Well, as you can see, it has been said here that we can increment the value. Yeah, so as you can see, we have been told that we can increment this set alphabets. That is, we can make a random A appearing in string 1 a B, or a C to a D, and a Z to an A. We can convert a Z to an A because of this keyword, that is cyclical. Alphabets go around from A to C and then from C to A. Okay, so how it works in this string? We are given a string ABC, which is our string 1, and a string 2, A, B. We iterate through our string S1 while keeping our S2 at hand. We keep a pointer at this A and we keep on checking in S1. Once we have found a match between these two, we move on to the next one. Suppose S2. Now we keep on checking in S1. We move to B. We check whether B is a match or not. B is not equals to D. Similarly, we'll have to check B plus 1. This B plus 1 represents its ASCII value, which is C. Now, C is not equals to D either. So, our condition isn't met yet. We'll be moving the pointer up by 1 and now we will be checking our C. C is not equals to D. So, we'll have to check its incremented version as well. Now, C plus 1 equals to D. Since D comes after C and D is obviously equals to D. So, our conditions have been met and we have returned a true value here. Now, in the second case, it is given ZC and AD. How it will work? ZC is our string 1 and it was AD. AD is our string 2. Now, we'll start checking from A. We'll have a pointer at A and we will start iterating through this string in this direction. We'll go to Z. Now, Z is obviously not equals to A. And so it does not satisfy our condition. But when we do Z plus 1, it gives us A. Since Z is the ending, A is the starting, and once we hit the end, we iterate back to A. And this way, the loop of alphabet keeps on going. Now, since Z equals to A condition has been met, we move on to our next string, which is C. While we iterate here once as well, we move on to D. Both our pointers are at these positions. And now we compare C and D. C obviously is not equals to D. So we do C plus 1, which is equals to D, and D is obviously equals to D. So here as well, we return true. Now, moving on to the third one. What have we been given here? A and B and D. Now, A and B and D. We have a pointer here and we start iterating from here. Now, A and A plus 1, which is equals to B, none of these are equals to D. So we will move on by one. We'll have our point at B. Now B and B plus 1, which is equals to C, are not equals to D either. Thus, we don't satisfy our conditions and we return false. So, what's the approach for this problem? The approach is quite simple. We have two strings S1 and S2 given to us. We'll have to take the size of both. Suppose S1 has a size N and S2 has a size M. We will be iterating through S1, which is we'll have a loop iterating N times. So let's write our for, which is going N times. Now, inside this for, we'll have to check for each statement. We'll be increasing I by 1 each time the loop iterates. And inside it, we'll be checking whether our current S1 of I equals to our S2 of J. As you have seen in these cases, you have to keep a pointer separate for both. This one is the J pointer and this one is the I pointer. The I pointer will keep track of our position in the string S1 and the J pointer will keep track of our position in string S2. So, if the string conditions are met, we do J plus plus, that is we move ahead by 1 in the string S2. Let's have an example string beside this. Suppose our S1 is A, B, C, D and S2 is B, E. So this is our J pointer at the start and this is our I pointer at the start. I will keep on iterating through S1. If no matches are found, it would return false, and similarly J will be rotating through this. Once a match is found, suppose this is a match since A plus 1 equals to B, so we'll move on to the next one and we will move our pointer here since this has already been checked. Now, in this condition statement, we won't end just here. We'll have to add a little bit more to it, which is, as you can see, S1 and S2 positions are checked, but we have to add the increment part as well, which is or S1 I plus 1, which is the increment, must be equals to S2 of J. This is how our problem is, since we have to check for the increment as well. But that's not all. As you have seen previously, we had a condition where z is equals to a, since z plus 1 equals to a. So what do we do here? We have 26 alphabets. And if we subtract from z 25, what will we get? Our a. Since the difference between a and z is 25. As you can see, if we do a plus 1, we get b. A plus 2, we get c. Similarly, a plus 25, we get z. The reverse is true as well. Z minus 25 equals to a. It's just simple maths. So that's the basic logic of our problem. Similar to this condition, if we do minus 25, this should be equals to this. That's our condition. If string 2 is not completely verified, we'll return false. Now let's head to the code. If I find something else you need an explanation of, I would do it. Heading on to our code, actually let's make our lives a little easier. Let's change these from str1 and 2 to s1 and s2. Now let's declare a pointer to keep track of our position in our second string. Now we need to store the size of our first string, which is s1 dot size, and similarly we will need another one to store our s2 dot size. This will store the size of our arrays. Both of these will be integer values. Now we need to iterate through the entire string s1. For that we will be doing int I equals to 0. This is another pointer I which will be keeping track of our position in string s1. And since we have actually two strings, suppose j ends, in that condition we'll have to exit the loop as well. So we'll have two conditions here. If I less than equals to n and j less than equals to m. But we'll only be incrementing I. Now, the main condition of our problem, which is if s1 of I equals to s2 of j, our conditions are met. We got a straight up match and we do j plus plus. That is, we move our pointer ahead by 1, which is our j pointer. If all our conditions are satisfied, we return true. Now, this is basically skipping a layer of checking, which I will explain to you in the notebook. We could have done is if j equals to m, which is that j has reached the end, we could have returned true. Similarly, the opposite of it, which would be an else, we could have returned false. But instead we did is return j equals to m. If j has already reached the end, it will return a true value, else it will return a false value. So we skipped a few lines of code. Now, our condition has not been cleared yet. We need to add the condition for increment as well, which is s1 of I plus 1. This will increase our alphabet in the line by 1. And similarly, for the case of z, we'll have to do our problem should be solved now. Let's run it once. It is giving some error to us. Let's see what the error is. Oh, sorry. I forgot to add this. Now let's check it. It's still giving some error. It was, oh, I keep on making mistakes. I'm so sorry. It has compiled successfully. So let's submit it and let's see what happens. As you can see, it has run with a complexity of O of n, which is very good. These are basically similar types of solutions. It depends on the machine you are running it. It's nothing to worry about. So our code has run successfully. Thanks you for watching. Hope to see you all in the next one.